Quantum computers are a new type of computer that use the principles of quantum mechanics to perform calculations and process information. They have the potential to revolutionize the field of computing and solve problems that are currently beyond the capabilities of classical computers. One of the key differences between quantum computers and classical computers is the way they store and process information. Classical computers use bits, which can represent either a 0 or a 1, to store and process information. Quantum computers, on the other hand, use quantum bits, or qubits, which can represent both a 0 and a 1 simultaneously. This allows quantum computers to perform many calculations in parallel, making them much faster than classical computers. Quantum computers also have the ability to perform certain calculations that are impossible for classical computers. This includes the ability to factorize large numbers, which is important for tasks such as breaking encryption codes. Despite their potential, quantum computers are still in the early stages of development and are not yet widely available. There are currently a few companies and research organizations working on the development of quantum computers, but it will likely be several years before they are widely available. The potential applications of quantum computers are vast, and they have the potential to solve many problems that are currently considered intractable. This includes problems in fields such as medicine, finance, and environmental science. There are a few potential risks or dangers associated with quantum computers. Security. One of the main potential dangers of quantum computers is their ability to break certain types of encryption. This could potentially allow unauthorized access to sensitive information and could have serious consequences for industries that rely on encryption to protect data, such as the financial and defense sectors. Unforeseen consequences. As with any new technology, there is a risk of unforeseen consequences when it is introduced. It is possible that quantum computers could have unintended consequences that we are not currently aware of. Control. If quantum computers were to become powerful enough, there is a risk that they could be used to perform certain tasks that are currently beyond our ability to control. This could include tasks such as predicting the outcome of complex systems or optimizing processes in a way that has unintended consequences. Quantum computers have the potential to solve certain problems significantly faster than classical computers. This is because they can perform certain operations on a vast number of inputs simultaneously, a property known as quantum parallelism. One example of a problem that quantum computers could potentially solve much faster than classical computers is integer factorization, which is the problem of breaking down a composite number into its prime factors. This problem is thought to be difficult for classical computers because it involves trying many different combinations of prime numbers, and the time required to solve the problem grows exponentially with the size of the input. However, a quantum computer could potentially solve this problem in a much shorter amount of time, making it useful for tasks such as breaking down large composite numbers for cryptographic purposes. Other problems that quantum computers might be able to solve faster than classical computers include optimization problems, machine learning tasks, and certain simulations. However, it is important to note that quantum computers are still in the early stages of development, and it is not yet clear how much faster they will be able to solve these types of problems in practice. Overall, quantum computers are an exciting development in the field of computing and have the potential to revolutionize the way we solve problems. While they are still in the early stages of development, it will be interesting to see how they are used in the future.